Hi, and welcome to this introductory course on Git, the version control software. What is Git? As I've mentioned, Git is version control software. That means it tracks file changes. We can commit and snapshot these changes. We can roll back to previous changes. And this can go on all the way back to the beginning of a project. It is free and open source and is very widely used. Almost every big or small software corporation or company will use version control in some way or another. And 90% of the time, this will be Git, either with GitHub, GitLab, Codeberg, or any other of those tools. What we will learn in this course. We will of course be focusing on setup and configuration at the beginning, using git init, git add, git commit and git log commands, git status and diff, the branching, merging and the conflicts that could arise, and how to work with remote repositories. Let's get started. Let's get started with the first steps by configuring a Git setup. The first thing, of course, you need to do is install Git, and then you can do -- version to check if this install was successful. You can install it using apt, dnf. On Mac you can use brew, and on Windows you can either install the git bash application or use winget to install Git. Just a small note, as you can see right here, I am using a Nix shell to have some dummy configurations because I use this computer for myself and I don't want to pollute the internet with my real Git credentials. So let's see. cd dot. I have my shell.nix, and in here you can see that I run a shell hook with some dummy data. I call my Git user Git student with student at example, and I also use Starship, which is just a small tool that gives a very nice terminal. So let's get into here and let's start with configuring. The final thing on this list is that we can actually check what we have set. At least that's what I thought. So we can do git config global, because all these configurations should be global. Unless you have like very repo specific things, and then you can user.name and then just student example, and we don't get anything back. But when we run the last command in my slides here, we can see that user.name is student example right now, right? We can do the same with user.email, because you of course need an email address, so student@example.com. And when we list that again, we can see that it has been updated. All right. So the command to create a new configuration is just git config with anything after that for the specific configuration you want to edit. For example, the text editor that you will use. Git will always use a text editor in the terminal for git commit messages. A lot of people use Nano. I actually prefer Vim. So let's just check if I even have Vim installed. Yes, I have. Because I'm using the Nix shell. Of course I have Vim installed. like so. And then when we do the -- list, we can see that core.editor, which is the editor that it will use, is now Vim. All right, let's go on to the next lecture and actually create a repository. Let's get started with creating our first repository. Right now, if I do ls-a to check all the files, including the hidden folders and files, I get nothing because I haven't added anything. So let's run git init. This will create a empty Git repository. And if I do ls-a right now, you can see that we have a .git folder. You will never commit this. It's just for local things, but it's very useful that you don't delete it. The warning that we get right here is just a hint that we are using master as our first branch name. A lot of people commonly choose main instead of master at the moment, and you can rename this with this command. You can also disable this message in the config, of course. But let's do that. Let's git branch m main. As you can see, my starship, my prompt, has updated the branch that we are on right now. All right. So let's just see what's in this Git folder, right? There's configuration, there's a description, the head, whatever that is, you know, hooks, info, objects, refs. We pretty much never need to go into that folder. So just know that it exists and that it has all the information of your repository. But let's get actually started with the fun stuff. So let's first create a new file, our readme.md. Nice git project, bro. Let's write and quit. And now when I do ls, I can see there's a readme file, right? Some IDEs will now give a message like, you've created a new file. Do you want to commit it, or do you want to add it or stage it? And we will not right now, or we don't get that message because we're working in the terminal. But we still want to commit this message because we want to have our initial commit, which is often just a readme. So we need to add this file, commonly also known as we need to stage this file, because right now if I do git status, we can see that we don't have any commits yet. We are on branch main, and we have some untracked files, which is our readme, and we can add this file with git add file. We don't have anything added to the commit, so we cannot commit anything right now. If we do git commit, you can see there's nothing to commit. But we can add the readme. Right now, if we do git status, we can see changes to be committed. New file called readme, which is cool. Another way to add files, which you probably will use a lot, especially in bigger projects, is git add dot, just a dot. This will commit or add all the untracked files that you don't have ignored. So any new files like this readme that we've got will now be added, because it is very cumbersome to just, you know, manually add the file each time. All right. So now that we have staged our readme, we can run git commit. Git commit will open your chosen editor, If you remember, I used Vim. And right here, above this line, we can enter a commit message. Initial commit. We can write this file. You can see that it saves in a .git folder, which is interesting to see. And all these lines will be ignored for the commit message. This is just for you. So let's quit. And right now we can see root commit, initial commit, one file changed, one insertion, which is one just the line that we added into the README. Create mode on the README. So if I do git log right now, we can see that we have a log with our student credentials from our config and a date and of course the name. We don't need to worry about the commit hash. It's just a unique identifier for your commit, which might come in handy in other times. We can also use git log one line to have a very short format commit log, which is very useful if you have like hundreds of commits, which isn't weird. All right, so you might have spotted that I have this line right here. We can use -m to add a commit message. So let's open our README. Let's add some text and let's commit it again. But let's just use -m. And then some text between quotes. Added a description. Oops. We haven't added it yet, so let's do git add dot to add it. And let's run git commit m again. You can see one file changed, 2 insertions. All right. That's probably just the new line that we added. And then our text. And we can see in the git log that we've added a new commit without Git opening Vim for us and then we having to type the commit message within Vim. We can just use -m to see it immediately. This has been a pretty long lecture, but this is the basics of committing and checking the logs, checking the status, everything you need to know for this. Let's go on in the next lecture. Let's go out by checking the diff, the restore, and how to reset your changes in Git. We can view changes with git diff. So if we run git diff, you will see a remnant from a failed attempt I previously had, which you will never see. So that's the only difference we have. If we check it out again, you can see that I had a file called new.md, which I deleted. So if we create it again, as you can see, we do git diff, we don't have any differences. I was sure I didn't log it, but I might have, yeah. All right. So let's check what we have in our README. It's the nice Git project pro. So maybe our company isn't really into thread culture. So let's remove the pro. Then we can check the diff that we have. And in our README file, we have this diff. We removed the line nice Git project pro and we added the nice Git project. Of course, we just changed the line, but this is how Git will remember it. If we check the -- staged, you will again see my failed attempt, but let's add all our changes, right? And we check the staged differences. Then we can see we have the new file and we have the README changes. But if we do git div now, we don't have any changes. So all of our changes have been staged, so they don't show in the regular Git div, right? So we have staged the changes. Maybe we want to unstage a change. For example, we are not ready yet to commit our new.md. So let's just git restore staged with our new.md. If we do git status again, we can see that it has been it's untracked, which is correct. We haven't committed it yet, so it's untracked. But if we restore the README, you can see that we have a change that's not staged, and we still have our untracked file. But let's add them both again, right? So we both have staged the files, but we want to we maybe want to add a little personality to our README. So this is our README right now, and we want to restore it to the previous version. Then I think we need to unstage it. So git restore the README MD. Okay, let's clear it, and then git restore our README. And now you can see that we have reverted our change to what our previous commit was. When we stage them, we cannot do this git restore again. We're like this, at least, right? All right, so this is a quick overview of how to use the git restore and git diff commands. And let's get into the next lecture. Get ready for a pretty long lecture. We're going to talk about branching and merging. I forgot a G right here, but it's fine. So right now we have just used our main branch, which we set with git branch -m main, right? Let's quickly check the status. Let's commit our new file. All right. Just so that we have a clear git log. Let's just do the one line. All right. So we have this right now, right? Let's maybe create a new branch. You can do this with git branch. Let's just say data. And then we can change, or okay, so git branch data, right? So Starship still thinks we are on the main branch, which is probably right. So let's list all the branches, and we can see we are indeed on our main branch. So what can we do? We can use git checkout and then data to switch to branch data, or we can use git switch to back to main. As you can see, git checkout data, Starship knows we're in data, and then we're back in main. You might have noticed on this previous slide that I've used git checkout -b name. This is a quick way to create and switch to a branch, a new branch, I should say, because if I do this with data, we get an error that branch named data already exists. So we can, I think it's uppercase D to delete the branch. Yes. So now if I do git branch, we only have the main branch. So if I do git checkout -b for branch data, we have created a new branch and we immediately switched to it. There you have it, right? Great. So now we have 2 branches, right? Between which we can switch. Let's just add a new file. Data.json. Let's add something right here. Oops. And just name Git. Whatever. Alright, so let's add this. Git add dot. Let's git commit it. Added data. And let's go back to our main branch. So we have a new branch right now called data, which is one commit after main. So main is lagging one commit behind. But we want to merge data into main because that's what you do. You create a feature in another branch and you merge that back into the main branch. We can simply do git merge data. That's it. We have our new data.json. And then you can delete the branch because you've merged it back. And if we do git log right now, we can see that we have the added data commit, which we used or which we created in our data branch. So what happens if you try to do some changes in both branches and you want to merge them? Let's find out. So let's update our data. So let's say we don't like the name Git. We want to name our whatever Vim. And then we commit it. And then we say Vim rocks. Let's add it. And then we say Vim rocks, right? And then let's do git checkout. -b. Sorry, new keyboard, still need to practice. -b, let's just say data again, because it didn't exist anymore, right? So we can create a new branch called data. And let's update the data right here as well. So no, we don't want Vim. I don't agree with it, but we want to use Nano. Now we have a problem. If we add and commit it, Nano rocks. Again, don't agree, but who am I? If I do git checkout main, because we want to merge data into main, not main into data, or at least not at this time. There's nothing wrong with it. You probably want to keep your branch updated, but for now we want to do it this way. Let's do git merge data. Okay. That's interesting. Vim, or name is Nano. But we said it was Vim, right? Vim rocks, Nano rocks. Oh, I'm an idiot. Sorry. Let's do it again. Data. Git branch data. Okay, so Nano is what we have in main, all right? And if we do git checkout data and we do get data, it's also Nano. So let's change it right here to Vim and then git add dot git commit m Vim rocks 2, sorry, keep speaking Dutch, and then we switch back to main. remember, I can use both git switch or git checkout to switch branches. And if I change it right here as well, vim, let's see, data, and we say Emacs, which is also pretty cool, but I don't understand it right. And then we git add, git commit, and it's Emacs rules. Enter. Okay, so right now we have the Emacs rules, and so we have our data.json, which is Emacs, and in the other branch, it's also changed, but it's Vim, right? So let's check out main. Let's clear this and let's merge data again. Whoa. This was what I was trying to force, but because I created the branch after I made the change, they both had the same starting point, so it didn't cause a conflict. But now we have a conflict in data.json. Interesting. So, as you can see, my starship says merging right here, right? And I think git status will also show something in this way. Fix conflicts and run git commit. And we have a unmerge path with which we need to add. So let's open Vim, right? And data. Whoa, what's this? This isn't our JSON, right? No, this is our, these are conflicts, like conflict markers, they're called. And pretty much every IDE will fix this in a much better way. Then you can just click which changes you want to add. Let's actually quickly try to show this. Let's see. Yes, I trust the authors. Thank you. All right. So right here, all right. Let's just check this out. We have this. This is our conflict, and we can resolve it in a merge editor, or we can accept current change, which is from the head, which is our current branch, or accept the incoming change from the data branch. We can also accept them both, which in this case you don't want, because then you have a duplicate key in your JSON. So within a editor like Visual Studio, you can simply accept or the incoming or the current change. But you can also do the same within whatever editor you want. So here we can see, okay, so our current changes it to Emacs, but the data branch changes it to Vim. And because I like Vim more, we can just remove the current change and remove the conflict marker. Then we just say git add, and we just say git commit. We don't specify a -m right here. And you can see that it will create this whole commit. Like it will mention the conflicts, and it will create a commit called merge branch data. So let's just accept that. And now if we check our history, we can see we have a merge branch data right here. And if we do cat data, you can see that we have accepted the incoming changes, but we have just done it manually. And the name is now Vim, because Vim is a very cool editor. Thank you for sticking with me during this lecture. It's been a lot, I know. But just know that you will encounter conflicts pretty often. But thankfully you will probably use an editor which is more suited for fixing conflicts. Thank you. Let's get started with the final basic knowledge that you need, working with remote repositories. And this can be GitHub, GitLab, or a local file. And I will use a local file because that's just a lot easier for me right now. It's just a URL that you will use. So let's get out of this and let's just create a bare repository. So we will call this fake repo or fake remote.git. We still get the same error, but we have a fake remote.git folder. All right. Then we can go into our course repo and we can say git remote add our name. Let's call it origin, which is pretty standard, and just do this, the fake remote.git. We can check our remote repositories with git remote-v. You can see we have origin, which is our fake remote.git, fetch and push. Let's do git push to our origin. We want to upload our commits to from the local to the bare repository. Origin main, sorry. With this, you can see we have pushed to origin, our main branch. It's done a lot of things. It has done it to our fake remote, and it has created a new branch because on the remote repository, the branch didn't exist yet. So if we do git pull, everything is up to date, of course. I'm just a solo developer, so this will always happen. But pulling will retrieve the data from the remote repository to your local branch. If we create a new branch, git checkout b new, and we want to push this branch, we might need to make some changes. We can say set upstream origin and then our branch name. Now our new branch is also added to the remote, and we can also git pull this. Let's just switch back to main and clear this. You will often see git give hints that you need to run this command. So if you want to run git push to push your commits and the branch doesn't exist yet, it will say you need to run git push set upstream origin branch. So what can we do now? Let's create a new folder and cd into this. As you can see, we don't have a repository right here. Let's just say git clone. What's it called? Fake remote.git. This could be your GitHub URL, right? Like GitHub. Let's just go to my .files. If you let's see. All right. It might be difficult to see, but right here you have this code button. If you click on this, you will see this SSH URL. You can also use HTTPS, but I often use SSH. You can copy that and you can paste it right here. But because we have a remote repository on our machine, we use this as our URL. Cloning into fake remote. So we have a fake remote folder. So I didn't really need to create a new folder, I guess. But right now, like, Okay, right? Let's just see if I can still create a Git pool. All right. So we now have 2. Let's just git checkout main because that's what our branch is. All right. So, okay, this is interesting, right? Let's just see if we can get these 2 repositories out of sync, which I think we can. Let's just vim this readme from second repo. All right. Git add, git commit, and git push. All right, so it's done all the things. Let's just cd the fig remote. No, I think it's called course. Oops. Cd course repo. And I think, yeah, so we can git pull. And I can still show the git pull, even though I'm a solo developer, which is pretty cool, but still this won't happen if you're a solo developer. Unless you're working on 2 machines, right? So pulling will just fetch everything from the remote repository. It will say the commit hashes, or at least part of the commit hashes, and it will fast forward it to the readme. If you have merge conflicts, you will get the conflicts, like all those things that we've discussed before. You can work with the branches, everything. So this has been Git in a nutshell, basically. You should be able to work with remote repositories. Platforms like GitHub give you all the steps to create a repository and how to use it, mostly. Git commit, the difference. We have checked how to stage files. We've basically checked out everything you need to know for a basic Git workflow. There are a ton of commands that you can still try to learn. There are some that I don't even see here, right here, that I sometimes use. For example, cherry pick. We have rebasing. We have tagging, which is interesting on GitHub if you want to create releases. There's still a lot that you could learn from Git or for Git, but the basics, you're there. If you followed along with this course for a bit, you will certainly be prepared well enough for a software development job. Thank you. Hi, and welcome to this very quick lecture on cherry picking. I have made my prompt a bit smaller because it was getting very long, which I did with just this, just so you know. So we're currently in our main branch and we have our data and we have our new branch. So we don't have any differences right now. Let's check out our let's check out a new branch, right? So feature / pick. So we have something to cherry pick later, right? We just need to do some setup here. So we have our new.md. Let's pick me. And we have git commit, pick me, git add, of course, and then git commit, pick me. And let's add something else. Don't pick me. And then git add, git commit, no pick. I don't really need to push this because it's all local anyway. So how to use git cherry pick? Well, if you just run git cherry pick, you will get a whole bunch of possible options that you have, like skip, abort, continue. There's a lot you can do. But for keeping things very clean right now, I will just show you some basic cherry picking. So if I do git log, we can see that we have our no pick and our pick me. I will just copy the commit hash of our pick me, and I will check out main again. So if I just do get new, we don't have anything in the new markdown, not folder but file, right? So git cherry pick, and then the commit hash. You can also use a partial hash, of course, and it will say, okay, one file change, one insertion. Git diff is empty, but if I run new.md, we can see we have the pick me, but we don't have the don't pick me text, right? So we didn't cherry pick a whole file from another branch, but just a single commit. And you might be wondering when this is useful, and in most cases it's not. But when you have a lot of branches and you need to copy some work from another branch, for example, someone is working on a hotfix and that or on a feature, and he creates something that you also need. Then you can cherry pick from his feature branch into your feature branch, and then you have the same code that you don't need to rewrite, for example, a shared component store again, right? So I don't really use this very often. I use it like once every 4 months, maybe. But it's very useful to know that it exists, right? So thank you for watching, and I hope that you will not really come across any instances where you need this. Hi, and welcome on an extra lecture on Git Bisect, a feature that I hope you will never need to use. How do we use it, and let's explain what it is about. We simply use Git Bisect to use it, and then we need to give it some good and bad commits. That sounds a bit like archaic and weird, so let me explain. I have created some commits, right? So I've created 5 commits. Okay, so that's not great, or that's fine, right? But something happened. We have some wrong code. But of course, if we have some wrong code, imagine we have some wrong code in a file that we haven't edited in ages. So our data.json is just a very small part of a big project. But somewhere along all those commits, and we don't know where it went wrong, right? Somewhere along these commits, it went wrong. So we check out our project on an older commit, like way older, and we check if the bug exists. And we see, okay, this bug does not exist. So up until that point, it was fine. And then we check out the most recent commit, and we see that the bug exists. So now it exists, and for example, 2 months ago it didn't exist. But where did the bug occur for the first time? That's where Git Bisect comes in. And that's why we need to give it a good and a bad commit. So just we know that somewhere along the line this oh no just happened. And of course this is a simple bug to spot because, well, no JSON parser will accept this. But if you have a lot of code, you cannot find it that easily, right? But you can check if the bug exists in a older or newer commit. So what git bisect does, let's clear this. We just say git bisect start. And then we say a good and a bad commit. We can also see that we have git bisect good or bad together with a revision. So let's git log and let's just see, let's git log one line, please. There we go. Let's just say this commit went right. So git bisect good with that commit hash. Then it says, okay, waiting for the bad commit. And let's just say that's the most recent one. So that's the one at the very top right there. So then we say git bisect bad and paste that commit hash. Okay, so it says bisecting for revisions left test. It uses a kind of binary search to find where the commit went wrong. So we can check if the commit went wrong. On a web development project, you would just run the project, test the feature, and see if it went right. So here it's still fine, it doesn't exist. Here we can see that it also doesn't exist, so it's good, right? And here something happened. A lot of commits happened in the meantime because of the hello world and the what now. But here we can say it's bad. And we are still bisecting. So right now we can say that it went bad again. And then it will say this. This hash is the first bad commit. So somewhere in this commit, the feature went wrong. So if I just copy this, git checkout, and then we say vim data, we can see that the oh no has occurred. But I'm detached maybe. Let's see, this is the some more. So git check out a previous commit, and then we can see that it didn't exist yet. So now we know something for sure, that on this line, so let's just clear this and go back to 6EB. On this line the error occurred, or the bug occurred. So why would this be useful to know? Well, if you are using some sort of version control like GitHub, you can very easily go to that commit hash, just look at the commit, look at all the changed files, and look at where it went wrong, right? Here it's very obvious where it went wrong, and we can see it and we can fix it. So what you would do now is just git checkout. I called it bisect, this branch. Git bisect stop, or what's it? Is reset. Okay. So we're back. Maybe it was just my shell nagging me. But right now we can just say vim data. We can fix the bug. And we can commit that, right? And now we have fixed the bug because we have found our bug with bisect. So yeah, a quick conclusion. If you followed along and you understand the example, then it's fine and you can leave. I will just give a quick recap to try and really explain how this would be useful. In a regular project, you don't have a single file or just a few files. So you really want to use some sort of version control software like GitHub, GitLab, whatever, to see what happened in the whole commit. Because some files have been changed and maybe you can already quickly spot where it went wrong. You can see, oh, this calculation is not what it should be. And if that calculation is something that happens very, very deep in your code, it would take very long to find out that it went wrong at that point. But if you can know where in your commit history it went wrong, you can see which files have been changed and which calculations may have been altered, right? So again, with that, I hope you would never need to use it, because that would mean you write very clean code, or your colleagues write very clean code. But it is a very useful feature to know. And when I first found out about this, I have probably used it, I think, 6 times in like 3 months. So it was very useful for me to know, because it made it very easy, because it was a spaghetti code base, right? But it made it very easy for me to find out where the bugs came from, like which files it occurred from, and then I was able to find out how to fix it. And with that, I wish you a very good day. Thank you. Thank you again for following this course and making it to the end. We've taken a look at pretty much everything that you need to know for a regular software development job. We've taken a look at how to stage, how to commit, how to work with remote repositories, even if they're a local file. But you will probably always use something like GitHub or GitLab. We've seen how to merge, how to create and delete new branches. We've seen how to fix conflicts both in VS Code and in any other text editor. We've seen how to work with the Git log. We've checked out a lot of things. And we have created some beautiful commits along the way. Thank you for following this course. Again, if you want to further improve your terminal workflow, you can take a look at my Vim course, my Tmux course, which is what I have used for this split screen view. And you can take a look at my other courses if you want. I sometimes give some free coupons as well, so you might want to check that out online. Thank you again for following this course, and I hope you have a wonderful day.